A 0.3 kilogram ladle sliding on a horizontal frictionless surface is attached to one end of a horizontal spring, which has a K constant of 500 newtons per meter, and the other end of the spring is fixed. The ladle has an energy of 10 joules as it passes through its equilibrium position. At what rate is the spring doing work on the ladle as the ladle passes through its equilibrium position? So we have to recognize those words. At what rate, that means what is the power, and at the time that it passes through the equilibrium position. So that is the instantaneous power. So the instantaneous power is given by the force times the velocity. At the equilibrium position, that's where the force of the spring is 0. So the instantaneous power at that moment, 0. Now the next question, we actually have to do some calculations. At what rate is the spring doing work on the ladle when the spring is compressed 10 centimeters and the ladle is moving away from the equilibrium position? Here's our position, x equals 10 centimeters, and the velocity is away from x equals 0. So I'm going to choose my initial position to be at the equilibrium point and my final position to be at the point in question, the 10 centimeter mark, because what I want to do is I want to find the change in kinetic energy from those 2 points, and I know that's equal to the work done by the spring. My goal here is to find how fast is it moving at that 10 centimeter point. I can find the force using Hooke's law, and the velocity is what I'll find using the work kinetic energy theorem right here. Okay, so my final kinetic energy is 1/2 mv final squared, and v final is that velocity at 10 centimeters. So that's what I'm trying to find right here. They told me at the initial point the kinetic energy of the ladle was 10 joules, so there's my 10. And then my initial position is 0. My final position is 10 centimeters. And now I can solve this equation for v final. You can follow the math along right here, and I get the square root of 50 meters per second. So my instantaneous power then is the force times the velocity. The force of the spring using Hooke's law is kx, and the velocity I just found, square root of 50. So k times x times velocity gives me my answer of negative 353 joules per second. Another name for that unit is watts. That's my unit of power. What is the sign? Well, just to double check, it's moving away from the equilibrium point, which means the ladle will be slowing down. So the spring is doing negative work because it is taking energy away from the ladle.